So we're finished with part 3. So we're going to go to part 4 now. We have to calculate the length of a vector. Determine the length of the following vectors. Vector OA. So before we calculate the length, we need to know the components of vector OA, which we calculated in the previous videos. Alright, so vector OA is the same values in terms of the coordinates as the component. So point A is located at -8, 12. So the position vector of OA will have the same values for the components, -8, 12, as discussed in the previous videos. Okay, so now we want to find the length of vector OA. So we write the two lines at the end, at both ends of the notation OA, which means length of. So this means length of. Alright, so now to calculate the length, we're going to use the Pythagorean theorem, basically, where we square the x component and add it to the square of the y component and find the square root of that. So the square root of x, the x component is -8 here. So when we square -8, really, we're going to get 64, because we're saying -8 times -8. We're also going to square the y component, which is 12. And so squaring -8, in fact, we didn't even have to put the negative, because once we square it, it's going to be positive. So 64 plus 144, and this will give us what? When we add 64 to 144, what we're going to get? So this is going to give us 4 plus 4, that's going to be 8 when we add the ones column. Then the tens column, this will be 4 plus 6, which is going to be 10. Carry the 1 and put on the 0, and that 1 plus the hundreds column, the 1 in the hundreds column will be 2. So square root of 208. Alright, so let's do that. Square root of 208 is going to give us 14.4, etc. Let's say we want 3 significant figures. We'll cut off those that are not part of 3 significant figures. We have the 1, the 4, and the 4. We have 3 non-zero digits there. So the first significant figure is 1, second is 4, and the third is 4. And so we chop off the rest. Since the very first one of those that we're chopping off is less than 5, we keep this 4 as 4. So that's going to be our answer corrected to 3 significant figures. Okay, so we can write that as our answer, 14.4 units. Let's take these off quickly so we can focus on the other one. Now the other one is vector OB, and the components of the coordinates of B is actually 10 on the x and 5 on the y. So we're gonna have 10, 5 being the components of position vector OB, and so therefore the length of vector OB will be, we're gonna square the x component, so that's 10 squared added to 5 squared, right? And let's put these in brackets. Now when we square 10, we get 100. So it's going to be 100. For lack of spacing, we'll just put 100. And when we square 5, we're going to get 25, which gives us 125 when we add them. Now when we find the square root of 125, we're going to get 11.180, etc. Now we only want 3 significant figures. Let's write that better. So I'm going to cut off from the 8 onwards. So 1, 1, 1. Now this third significant figure, are we going to add 1 to it or leave it as it is? We check the very first of those we're cutting off. Since it falls in the category of 5 or more, yes, we're going to add 1 to the one that we have at the end there. So because of the very first digit we're cutting off, which comes after this one, which is an 8, we're going to add 1 to this one to make it to 2. And so it's going to be 11.2 units. Next one, let's look at vector AB. So remember we said to get vector AB, we're going to go from A, the starting point A, to the origin, and then from the origin to the end point B, because we need a transit point in this case. AO we said is the opposite of OA, so it's be 8, -12, added to OB, which is 10, 5, and when we work that out, we're going to get 18, and that's going to be -7, which means from A to B, we're going to go 18 to the right and 7 down, which makes sense. Alright, so now we're going to find the length of vector AB. So we're going to square the x component. The x component is 18, so we're going to square that, add it to the square of the y component. Alright, so we're going to square the the 18. I'm going to get 324. And then we're going to square negative 7, which means negative 7 times itself, which would be positive. Negative times negative is positive. Positive 49, that is. We add 49 to that figure. We get 373. So that's the square root of 373. And what is the square root of 373? That's going to be, since 373 is not a square number, it's going to give us a decimal. So 19.31320, etc. Now we only want 3 sig fig. 1, 2, 3. So we'll chop off the rest. And the very first of those we're chopping off is a 1. And since it's 1, it falls under the category of less than 5. So we're not going to add 1 to this third significant figure, the last of our required significant figures. So we're going to keep it as a 3. And that's going to be our answer to correct it to 3 significant figures. Alright, so that's going to be 90.3 units. Alright, so in the next video, we're going to look at calculating the acute angle a position vector makes with the x-axis.